Hi students, because of lockdown we all are at home and I hope you are stay safe and at home and happy. Today we are going to start with our subject physics, our first chapter, that is rotational dynamics. In rotational dynamics, first topic, that is a circular motion. In circular motion we are going to recall these four concepts. Among these one, first one is a radius vector. Now all you know the circular motion. What is circular motion? Circular motion, motion of a particle along the circumference of a circle. We say that is nothing but the circular motion, that when a particle is revolving along the circumference of a circle. What is radius vector then? Next one. Radius vector, a vector drawn from center of the circle to the position of the particle. Which position or which particle? That particle which is revolving along the circumference of a circle. So when we say the vector, in 11th standard we have studied about scalars and vectors. When we say the vector, then vector magnitude and direction. Vector has magnitude as well as direction. So we say that magnitude is nothing but the radius of the circle. What about the direction? Direction of a radius vector is always outward. Outward, or we can say that it is away from the center of the circle. That particle is revolving along the circumference of a circle and I draw a vector away from the center, then we say that the vector is nothing but the radius vector. Then next one, angular displacement. Suppose after, let us say this position is A, and after time, let us say time t, the position reaches or the particle reaches at the position B. Here the radius vector makes an angle at the center, and this angle is nothing but the angular displacement, and this angular displacement is denoted by theta. Then next one, let us say angular velocity. Angular velocity, same as the linear velocity, or for the linear motion, same as angular velocity. Angular velocity, we can say that rate of change of angular displacement with respect to time, and it is denoted by omega. Here I write a short formula for that one to memorize yourself, that omega is equals to d theta by dt, rate of change of angular displacement with respect to time. Here the direction of angular velocity is given by right hand thumb rule. Now what is right hand thumb rule? If you curl your fingers, when the particle is revolving like this, I curl my fingers, right hand fingers like this one, then omega, that is direction of angular velocity, is outward. In another figure, if I curl the finger like this one, then the direction is inward direction, or if I say this one, then it is outward direction or upward direction, and here you can say that it is in a downward direction. That direction of angular velocity is given by right hand thumb rule. Then angular acceleration, same as that of the angular velocity, it is denoted by alpha. Angular acceleration, alpha is equals to rate of change of angular velocity with respect to time. Alpha is equals to d omega by dt, rate of change of angular velocity with respect to time. Now we can say the direction of omega, or let us say angular velocity, is given by right hand thumb rule. Same angular acceleration, the direction of angular acceleration is given by this angular velocity. With the help of this angular velocity, for example, if I switch on the fan, the angular velocity is increasing. When the angular velocity is increasing, the direction of alpha is in the direction of angular velocity. So we say that angular acceleration is in the same direction as that of the angular velocity when the angular velocity is increasing. But if angular velocity is decreasing, then the direction of angular acceleration is opposite to that of angular velocity. What I say, I repeat, angular acceleration have opposite direction of that of the angular velocity when angular velocity decreasing, that is with respect to time. Then there are two characteristics of a circular motion. First one, circular motion is a accelerated motion. Now why it is accelerated motion? Again, acceleration. What is acceleration? Rate of change of velocity. That when velocity changes, then there is acceleration. Here, if I say accelerated motion, in accelerated motion velocity changes. I am not talking about speed. Be careful about speed and velocity. Speed is a scalar quantity, whereas the velocity is the vector quantity which has magnitude as well as direction. So here, if we study either uniform circular motion or non-uniform circular motion, in uniform circular motion, we can say that the velocity of a particle changes but speed remains constant. That particle revolving along the circumference of a circle with constant speed, but velocity is tangential, like this one, which we already studied in 11th standard. So velocity, direction of velocity changes, so we can say that it is nothing but the accelerated motion, whether the motion is uniform circular motion or non-uniform circular motion. In non-uniform circular motion, magnitude as well as direction changes, but in uniform circular motion, magnitude remains same but the direction changes, so we say that circular motion is accelerated motion. The next one, it is periodic motion. What is periodic motion? That the path in circular motion, the path repeats itself again and again. For example, if I tie an object to the string and revolve in a horizontal circle or a vertical circle, it repeats its path itself. In uniform circular motion, it repeats its path itself with equal interval of a time, but in non-uniform circular motion, it repeats its path. So we can say that the circular motion is an periodic motion. Two characteristics: accelerated motion, that is circular motion is accelerated, and it is periodic motion. Then kinematics. Now for kinematics, there are two concepts: centripetal force and centrifugal force. Now what is centripetal and centrifugal? Before studying centripetal and centrifugal, let us come to angular acceleration and linear acceleration. When we say linear acceleration, then it is linear motion, and angular acceleration either rotational or circular. Radius vector is in outward direction. मी अगोदरच सांगितलेलं आहे की रेडियस वेक्टर कोणत्या डायरेक्शन मध्ये आहे? आउटवर्ड डायरेक्शन मध्ये आहे. इफ आय से द acceleration, that is linear acceleration, the direction of this linear acceleration is inward direction, or we can say that it is nothing towards the center of the circle. So this acceleration is called as centripetal acceleration. Direction of this acceleration is towards the center, so centripetal. It is along the radius, so it is also called as radial acceleration. Why it is radial? Because it is along the radius. Why it is centripetal? Because it is towards the center. So centripetal acceleration, according to Newton's second law, we can say that force is equals to mass into acceleration. So centripetal force we can write here. I write here centripetal force is equals to, I write the equation that centripetal force is equals to, according to Newton's law, force is equals to mass into acceleration, and centripetal force we can write mass. Now acceleration, 11th standard relation for the acceleration is v square by r. It is opposite to the direction of radius vector, so I write a negative sign. This negative sign indicates that the direction of radius vector and force is opposite to each other. Radius vector in outward direction and centripetal acceleration same for the force. So negative sign indicates that it is opposite to each other. This is centripetal force. Centrifugal force. Centrifugal परत एकदा आपण थोडंसं 11वीत जाऊया. आणि 11वीतली जी कन्सेप्ट आहे सुडो फोर्सची, ज्यात मी बरेचसे एक्झाम्पल तुम्हाला 11वीत आपण डिस्कस केलेले आहेत. कारचं एक्झाम्पल असेल, मेरी गो राऊंडचं एक्झाम्पल असेल, त्यातलंच मी एक एक्झाम्पल घेतोय. दॅट वी आर गोइंग टू स्टडी द एक्झाम्पल ऑफ मेरी गो राऊंड. Merry go round, when the merry go round starts, then you have a sudden jerk to the outward. Who pulls outward? What is the force? Why we give or why we take that jerk? That jerk is because of centrifugal force. But as the merry-go-round revolves and it becomes steady or stationary, like revolving with a constant speed, then magnitude of centripetal force and centrifugal force is same or equal, and for that one we can write this equation for force, that real force mv square upon r plus summation of real force is equals to 0. This is the equation mv square by r plus summation of that real forces is equals to 0. Centripetal force, it has some specific origin, so we can say that it is nothing but the real force. Centrifugal force, it does not have some specific origin, so we can say that it is not an real force or it is a pseudo force. Then in a kinematics, there are 3 equations for linear motion as well as for angular motion. लिनियर मोशन साठीचे एक्झाम्पल्स किंवा जे इक्वेशन्स आहेत 3 इक्वेशन्स, हे देखील आपण 11th स्टँडर्ड मध्ये डिटेल मध्ये, और यू कॅन स्टडी इन 9th 10th स्टँडर्ड्स ऑल्सो. सो वी कॅन से दैट फॉर लिनियर मोशन देर आर 3 इक्वेशन्स. फर्स्ट वन, v is equals to u plus at, where v is nothing but velocity, let us say final velocity or velocity after time t. U is nothing but initial velocity, a acceleration, and t time. S is nothing but displacement, and for angular acceleration, same as that of the v is nothing but, we can say, linear velocity after time t. Here we can say that omega is nothing but the angular velocity after time t. Omega 0 linear angular velocity, initial angular velocity. Alpha is nothing but the angular acceleration, as already explained. Then theta is nothing but angular displacement, and t is the time. So we can say that it is analogous to write that equation for angular motion. So we can say that v is equals to u plus at. I write the same equation, omega is equals to omega 0 plus alpha t. S is equals to ut plus half at square. Same here we can write theta is equals to omega 0 t plus half of alpha t square. V square is equals to u square plus twice s for linear motion, and for angular motion we can write omega square is equals to omega naught square, or let us say omega 0 square plus twice alpha theta, where you already know the signs or notations for that all these 3 physical quantities, let us say angular displacement, velocity, and acceleration. Then we are going to study the next topic. Next topic, for that one I erase this circular motion topic, and for that one, applications of circular motion. There are 4 applications. Applications of circular motion. 4 applications are there. First one, vehicle along horizontal circular track. Then second one, sphere or well of death, let us say well of death. Up well of death. Third one, a vehicle along or bank road. Vehicle on a bank road. Vehicle on bank road. And last one, fourth one, conical pendulum. Now, 4 applications of a circular motion, that how or why to study the circular motion. Vehicle along a horizontal circular track, well of death, ज्याला मौत का कुवा असंही तुम्ही ऐकलेलं असेल कदाचित. मौत का कुवामध्ये सर्कस मध्ये जर पाहिलेलं असेल तर मौत का कुवा असतो, दॅट इज वेल ऑफ डेथ. देन व्हेकल ऑन अ बँक रोड अँड लास्ट वन कोनिकल पेंडुलम. वी आर गोइंग टू स्टडी नाउ फर्स्ट वन, दॅट व्हेकल on a horizontal road, horizontal circular road. Horizontal circular road. Let us consider a circular road having a center C at having radius vector r, and vehicle, consider the vehicle as a point. Here we are going to consider, to study that relation, we are going to consider that vehicle is at a point, or vehicle is like a point. 2 forces acting on that vehicle. First one, upward force, that is normal reaction, and downward force because of the gravitational force, that is weight mg. Then static frictional force, let us say that force is nothing but Fs. And this Fs, we already studied, the force towards the center of the circle is nothing but the centripetal force. So centripetal force, I write here, centripetal force is nothing but mv square by r. We are going to take only magnitude here. So centripetal force is balanced by this static friction. Normal reaction is balanced by weight. So I write here, normal reaction is balanced by mg, and centripetal force mv square by r, and this is balanced by Fs, let us say. For our simplicity, I write this equation like this: Fs is equals to mv square by r. I call this one as equation number 1, and I call this one as equation number 2. If I divide equation 2 by equation 1, then Fs upon n is equals to, I divide equation 2 by 1. Fs upon n is equals to what we write, mv square upon r, and this mg, I write here mg, this m gets cancelled, and we get here v square by rg. But Fs upon n, what is Fs upon n? Fs is equals to, we can write this, force is nothing but n into mu s. What is mu s? Mu s nothing but the coefficient of static friction. Coefficient of static friction. So Fs upon n is equals to, obvious, Fs upon n, if I take n to this side, then Fs upon n is nothing but mu s, and mu s is nothing but coefficient. We are going to put that value, same value. So we can write here mu s is equals to v square by rg. What is our aim? To find out the velocity along the horizontal circular track. So we can write here v square is equals to mu rg. If I take the square root, then v is equals to square root of mu rg. So this is the maximum speed along the horizontal circular track when the vehicle is along that road. Consider road is like this one, and this center is here. This is the maximum speed. If I want to increase the speed further, this one at the same road, सपोज मला एकदमच काय करायचं आहे की घरी जाण्यासाठी खूप उशीर झालेला, मला एकदम थोडासा स्पीड वाढवायचा आहे. जर मी जास्त स्पीड वाढवलं तर आपण जी कन्सेप्ट अगोदर घेतलेली आहे सेंट्रीफ्युगल फोर्स, त्यामुळे काय होणार आहे, मी जर सडन स्पीड वाढवला तर माझी जे व्हेकल असणार आहे ते कुठे जाणार आहे, या बाजूला, अवे फ्रॉम द सेंटर ऑफ द सर्कल. अगोदर सांगितल्याप्रमाणे की या बाजूला व्हेकल काय होणार आहे, पडणार आहे. मग मला जर स्पीड वाढवायचं असेल तर 3 गोष्टी वाढवाव्या लागतील. कोणत्या? फर्स्ट वन, वी हॅव टू इन्क्रीज कोएफिशियंट ऑफ स्टॅटिक फ्रिक्शन, देन रेडियस, अँड देन ऍक्सलरेशन ड्यू टू ग्रॅव्हिटी. यातली फर्स्ट वन, ऍक्सलरेशन ड्यू टू ग्रॅव्हिटी, ही आपण वाढवू शकत नाही. ऍक्सेलरेशन ड्यू टू ग्रॅव्हिटी इज बिकॉज ऑफ द अर्थ. सेकंड वन रेडियस. जर रेडियस वाढवायची असेल तर स्पेस खूप लागणार आहे, एकदम मोठा रोड करावा लागेल मला. दिस इज नॉट पॉसिबल. एकच राहिलं फक्त कोणता, म्यू एस. व्हॉट इज म्यू एस? कोइफिशियंट ऑफ स्टॅटिक फ्रिक्शन. आणि कोइफिशियंट ऑफ स्टॅटिक फ्रिक्शन जर मला वाढवायचं असेल त्यासाठी मला काय करावं लागेल, सरफेस जो आहे, सरफेस म्हणजे आपण कन्सिडर केलेला हा रोड, या रोडला काय करावं लागतील मला, हिल्स अँड डेल्स, थोडेसे खड्डे करावे लागतील की जेणेकरून टायर आणि रोडची ग्रिप वाढेल. पण दिस इज नॉट लायबल इन रेनी सीझन. इट इज नॉट लायबल इन रेनी सीझन when we do that, or it is also there is a wear and tear of a tires also, so we cannot increase the speed at this road particular or beyond a certain limit. So best remedy on this topic or along a horizontal circular road, best remedy is vehicle along a bank road. Now what is bank road? We are going to discuss this topic in the next lecture and the next video. So thank you for this one.